Taming the wild beast of a new photopolymer resin without a preset material profile for your Resin 3D printer can be a daunting task. But when wielding the powerful Origin One, Stratasys' industrial P3 DLP powerhouse, fear not, intrepid makers. For this video will illuminate the path to establishing optimal exposure parameters for a newfound resin. This will unlock the Origin One's full potential. Phase 1 of our plan involves gathering our arsenal. We are going to need our new photopolymer resin. This is the star of the show. We want to ensure that its datasheet is readily available. We also need GrabCAD print and our Origin One. And we are going to need a calibration model. You're going to have to download or design a small detailed model with various features like thin walls, sharp corners, and overhangs. This will act as your testing canvas. Today, I will be using Michael's calibration matrix, which I downloaded from our friends at Ultimaker Thingiverse. This is a brilliantly designed and comprehensive toolset, which includes exposure triangles, varying cones, checkerboards, depth elements, slits, and more, each crucial for assessing printability, resolution, and dimensional accuracy. The model also contains two nifty breakout parts, a 3mm internal diameter tube that fits onto a protruding 3mm cylinder, and an M3 nut, which may fit the M3 screw next to it, depending on how well you have your printer's resolution and exposure dialed in. All of these print evaluation features packed into a quick printing and low material utilization package make this a superb tool for exposure calibration. You will also need to have an OpenAM license for your Origin One. This allows you to create a new material profile within GrabCAD Print and adjust the exposure parameters to specifically suit your new resin. Our next step is going to be to do some reconnaissance, research into our new resin. We need to delve into the resin's datasheet, unearthing its secrets. A few of the key things that we need to take note of are the wavelength. We need to identify the light wavelength that the resin responds to ensure that it is fundamentally compatible with our system's light engine. We should consider the viscosity. Higher viscosities might require longer layer cure times. Is this a rigid or elastomeric material? Elastomers need different distances and delays than rigid materials. Do we need to warm the resin before printing it? How about a recommended layer thickness? A good initial value for our test prints. Our next step, in GrabCAD Print, instead of creating a new profile from scratch, I will select the profile of a resin that has similar characteristics in terms of viscosity, printed green strength, color, and opacity to our test resin, and create a copy. I do this so that I can work with a template material profile that has Z-stage movement speed values close to what we are going to be looking for. Then, I will go through and modify the values in all of the profile's editable fields to match what is represented in the test resin's material datasheet as best that I can. A useful list of definitions for all of these parameters can be found in GrabCAD Print's online documentation. I will be releasing videos that delve into the relationships between various exposure parameters and their further optimization in the future, so if this type of information is useful to you, make sure to like and subscribe to GoEngineer's YouTube channel. After setting the initial exposure parameters, I will change the number of transition layers to 0 and clear the data for the transition layers. Don't worry. It's easy to get them back, but we do not need them interfering when establishing a resin's baseline exposure parameters. Then we update our test profile, and we are all set to print our first calibration model. When setting up the print, make sure that you have your test material profile selected and that the part is centered on your build platform, and then send it to the printer. After post-processing, we need to analyze the results by comparing the print's features against the instructions that come with our nifty calibration model. We should look at the model comprehensively under magnification to see how both positive and negative features look. Our goal is to establish the precise exposure settings that will yield the best balance of geometric integrity between those two elements, positive and negative. One of the best indicators as to where you are on the exposure scale are the calibration matrices.
The cones of calibration.
If you have your exposure parameters dialed in well, the only cone that should fail building is on the far right. All of the others should be intact. If you are overexposed, all of the cones will build and touch their respective support platforms. If more than the cone on the right fails, you are underexposed. Once we have an idea as to where we are on the exposure scale, we can move forward. To refine our exposure parameters, first create an iterative copy of your test resin's material profile and open it up. If you determine that the parts are undercured, increase the exposure time slightly and reprint. If overcured, decrease exposure time slightly and reprint. If you see layer lines or loss of detail because of slight shifts in the layers in XY, increase the delay times between exposures. Update your new material profile iteration, close it, and then make sure it is assigned as the material for the next build, and then send it to the printer. Now begins the iterative dance. From here, we embark on a journey of refinement, repeating the print, analyze, adjust cycle until the calibration model emerges victorious. Sharp edges and crisp details standing proud, undercured areas and warping vanquished, layer lines fading into obscurity. Once satisfied that you have fine-tuned the exposure and delay times for optimal results, you can get down to business and start cranking out beautiful 3D printed parts using your new resin and your Stratasys Origin One. Thanks for watching, friends. Until next time, this is Richard Cromwell at GoEngineer, signing off.